In this simulation, we're gonna see what it takes to make something move in a circle. So you see that there's two arrows, there's the motion and there's the force. So if the force is pointing in the same direction as the motion, let's see what happens. It moves in a straight line. It speeds up and it moves in a straight line. Now, let's look at another case. Let's say that the force is directed 90 degrees to the direction of motion. So you're moving to the right, but you feel a force pointing perpendicular to your motion. So in this case, 90 degrees. Let's see what happens here. So if you notice there, it moves in a circle. So what it takes to make an object move in a circle is that you have to have a force that points perpendicular to your motion. And this is the same mechanism that keeps the Earth orbiting the sun. First, if you notice the force of gravity, it points inwards, and the velocity of the Earth is actually perpendicular to the radius of the circle or of the orbit. So if I fast forward this, maybe zoom out some, you notice that the Earth is moving around the sun in a circle, and the force is pointing towards the center of the circle, but the velocity of the Earth is pointing perpendicular to the radius of the circle. So let's look at the path. So you can see it again here. The Earth is moving in a circle. The velocity is perpendicular to the radius of the circle, but the force is pointing towards the center of the circle. So because that force points towards the center of the circle, we're going to call that the centripetal force.